Alright, so this is an add-on or continuation of the previous video. We're making a model in Altair Hypermesh to solve the following problem in Nastran. So we're using Hypermesh as the preprocessor. It's a plate with a hole in it under remote tension, and we're using the quarter plate symmetry here. Alright, so we've set up the materials and the property cards and then the component, which is the collector that's going to hold all the elements for the quarter plate model. Now we just have to define the geometries and then mesh it. So typically, in practice, you're importing geometries from a CAD package like NX or something like that. And in that situation, or Pro Engineer, you're importing in an IGES file or a native file, and then you mesh that directly. We're actually going to create the geometry in Hypermesh. Sometimes it's actually easier just to create the geometry because you don't have to do the cleanup like you do when you import in CAD geometry. And that's a whole other topic that I won't go into, but we'll make the geometry. So when it's a planar geometry, all that you really need to do is define the bounding curves for the geometry. Maybe I should use a different pen with a different color. Here's red. So all we need to do is actually define not the surface itself, but really the curves that bound the surface. And then we'll use the planes function under the 2D mesh menu to generate a mesh inside these bounding curves. And then to define the curves, you actually need to define the points. So for example, to draw a line from here to here, we need to define points here, and likewise for this edge. So I'm actually going to need to define some points as follows. So I'm going to define a center point. I need that to make this arc, and then we'll put points at all these sort of corners here like this, okay? Once I make the points, and actually Hypermesh calls them nodes, they're not necessarily the same nodes that go onto your mesh, then we'll connect the points using line and arc or circle, and then once we have the bounding curves, we'll mesh it, okay? Alright, so let's do that. So first thing to check is that the plate component is active, so that means the geometry will go into that collector. Click on the geometry radio button, or we'll pull down stuff from here. So if you pull down from geometry, we're going to create some nodes, and we'll do it by just typing in the XYZ coordinates, all right? So we'll put the first one at 0, 0, 0. So I don't have to change any of these. I just hit create and it's there. And I think we should see it. Let's change the orientation. So I'm looking down the z-axis. Okay. And here's the node I just created. That's the center of the circle. So let's make this right edge point of the circle. So we'll make this point. So that's going to be at the radius, and then 0, and then we'll go out here to W on 2, so on and so forth. So the next point will be at the radius. The radius is 2, so I put it at 2 there. Create. There's that point. The next point on the edge is going to be half the width. The width of this thing is 18 inches, so that's out at 9. Create that point. So we can also create the top corner, which will be at 9, and then half of 36. You can actually even do calculations, like you can double click on the field. I think it's to double click. If you go into here, I thought you could. 36. 36 divided by 2? I think you can do stuff like that. Like if I do 36 divided by 2. It didn't do it. There used to be a way to do a calculator on this. I don't know how to do it. Oh, there it is. If I right click on it, you can see now I get a little calculator pops up. I can do 36, enter 2 divide, so that gives me 18, and then I can enter that in, exit. You can see it changes to 18. So you can use that little calculator if you right click on the field to do some calculations if you want. Okay, so now I've got 918. That's the upper point there. It's probably off my screen, so we'll click on this. Where's the zoom to fit? I think this is zoom to fit. Is that zoom to fit? This is zoom to fit? This is zoom to fit. There it is. Zoom to fit. Come on. Maybe I didn't create it. Let's try it again. All right, there it is. Okay. And then the point over here will be 0.18. And then finally we need to do the radius point down here. So that'll be at y equal to 2, x equal to 0. All right, so now I've got all the points that I need. Okay, we can hit return. You want to save, you should probably save this every now and again. So we could do save, and this will just save as a Hypermesh file. So this really isn't something that Nastran or any other solver can read. It's something that Hypermesh reads, and it has other information in it. You can then, from that file, export to whatever solver you want. So we'll save that as just plate.hm. So that's a Hypermesh file. It contains all this stuff. You can exit and load that up again. All right, let's draw the lines. So geometry, create lines, and we'll do it linear nodes. I think that's all I need to do. Create. Pick the two nodes. You see it. Once you pick the two nodes and hit create, it draws the lines. There you go. Now we need to draw an arc. I never know how to do this. I mean, I guess it would be a create. I guess it's under lines, and then you would have arc, and we were going to do an arc radius type of deal. Okay, you can do, I guess we could do arc 3 node. No, I don't have 3 nodes on it. It has to be 3 nodes on the arc. So we're going to do arc, or is it arc center radius? Okay. So we're going to first pick the center point, I think. That's this one. Yeah, I should talk about this a little bit. This is kind of weird. This always pops up in Hypermesh. You can kind of have different select options here, and then this button actually clears the list. You can see actually if I pick the center point, there it goes. And so that node list, highlight that, and then click the center point. And then this next one says, well, an arc has to lie in a plane, so you have to define the plane that it lies in. So we're going to put it in the XY plane. So you have to define a normal vector to that plane. So that's going to be the z-axis. And now you can type in the radius. We know the radius is 2. And then the angle is the angle of the arc. And I think you can just put it 90. Let's see how that works. And it did it. You might have got, if you get an arc over here, you'll have to put the offset angle, I believe. Okay? But that one happens to work. All right. So there we have the lines and the arcs. All right. Save it. So remember, the approach was to draw the nodes, connect it up with lines and arcs. And actually, on this one still, I'm used to doing it down here, doing nodes. You can see you type in the nodes. Or lines. There's the line menu. And this is something new I haven't seen before, but this is something new in the new version. I don't know exactly what that does. And then the last one is that we used was arc. Where's arc? Is it underlines? Sometimes it's underlines. Oh yeah, see, it's underlines. You can make it do these different ones, pick different modes, and that's, I guess, what this is doing. So you can do like tangent between 2 points. You can do a conic. Okay. Then you just got to fool around with those and figure out how they work. I honestly don't do it all that often. So, okay. There you go. So now we got the lines. Now we're ready to mesh. Actually, we don't have to create a surface to mesh. The Hypermesh will automatically do it. Is for geometry that lies in a plane with just the boundary lines. Okay, so if you have geometry that's fully in a plane, you can just draw the lines that bound the surface, And then if you go under 2D, so this is the radio button that gives you the options for doing 2D meshes, or under here I think it goes under mesh. See, it's a little different here. Here it puts everything together, so you have to do mesh. You know, it's not really here, is it? They have the 2D auto mesh, but that's not what I'm looking for. I'm actually looking for the plane mesh. So some of the things up here, I guess, aren't. Some of the things down here aren't all up here. So anyway, or if it is, I can't find it. So let's go to the 2D mesh generation panel, and we're going to do planes. There's lots of different ways of doing this stuff. Like if you have a surface, you can do auto mesh. You can do ruled surfaces, spline-bound surfaces. You can do a drag. You can take a line and drag it along a generator curve and make 2D elements. But we're just going to do planes. I use this a lot. So planes, you know, we're not going to make it a square. It's going to be trimmed because we have bounding curves. Now we pick the lines, and that includes the arcs. So we just pick them all. And we've picked them all. And then you hit create. And it makes a mesh, and it's pretty lousy. Okay, so it tried to make a mesh, and it's a very coarse mesh. This is where you can go and change how you know, this is something that you want to really get to learn how to do in Hypermesh, because the quality of your mesh is really important. So there's a couple of things that you can do. One is, you know, there's element density and then there's element size. All right. So you can set globally the size of an element. So let's try to set it at like 1. And then if I do recalculate all, you can see it starts to give me a hint of the element distribution. So I can do a reject, throw out that old mesh, and do a mesh. And you can see here it gives me a mesh. That's not a bad mesh, okay? If I like it, I can hit return. If I don't like it, I can hit reject. All right? Let's say I wanted to add some more elements here. I'm sorry, some more nodes here. Okay? You can actually do that. You can use this element density, right? And I can actually individually pick an edge. So if I pick the edge, it set it to 1. Okay? Because that's what I had the value set to. Now, I can also right-click. If you hit adjust edge, then you can do like right click and left click. Well, I used to be able to do that. Let's do reject again. Let's do recalculate all. Okay, where are we going? All right, let me start over again. Let me do a board. Let's start again. So we pick the lines, and then we hit create. So it makes the very coarse mesh. Let's get the size to be about 1. We recalculate all. So there's the mesh for that one. Now if I wanted to bump this up, I click on the... They got rid of that. It looks like they got rid of that option. You used to be able to toggle and add more nodes here, but okay. That was set to 3. Let's make this more like 5. And I'm going to set this edge to be 5. So now it has 5 nodes here. You can see how that mesh will look. Okay, so it added some more elements on here. I can control it, you know, so you can control things that way. It's actually kind of nice. Actually, maybe that isn't even enough. Let's make it like 10. And let's set that edge. So we'll click it to 10. And you can see the mesh the results from that. Now that's getting a little weird because it's really going to have a tough time getting fine mesh here and then getting out to the coarse mesh. So you can see my elements are starting to get very distorted. So you can do other things. We could add more on this edge and this edge, but in fact, we want to add more nodes, but pack them more towards this edge. So you can do what's called a bias. So if I pick a bias, I can actually set a bias here. Let's pick the edges. We'll make this linear. And then this one. We'll set this edge to 3. And then this one to 3. And you can see what it does is the bias packs the elements towards a point. So this looks good. I got that packed more to this. And the more I change this bias number, the more it packs them to it. Now this one is packing it to the wrong side, so I think I make it -4 or 1/4. I don't know which one it is. Yeah, you make it a negative number, it packs it to the other side, okay? So that's kind of nice. So now we can do a reject, and now if we mesh again, you can see it starts to get a little better because we've added more nodes here. Now, probably what I should do is go back to the density and put in some more nodes on this side. So let's set this to 10. Add a couple more in there. Come on, Niche. There it goes. Now we set that to 10. And maybe we should bump this up. Instead of 16, we can make that like, let's make it like 20. Well, yeah, let's do 20. So put 20 on that edge. And then we can do a reject. And we can mesh it again. And that looks kind of nice. I've got a more refined mesh here. And I'm going to get a stress concentration here. I don't need such a fine mesh out in the far field. And the elements look kind of nice. So we can talk about checking the elements later on. But that's the way it goes. And I think it's a good idea to fool around with these different ways of generating the meshes. It's actually quite powerful. You can also have it generate just quadrilaterals, mixed quadrilateral and triangles, or only triangles. So actually the way this is set is it's set to mixed, all right? And what it's doing is it's using quadrilaterals when it can, but sometimes the quadrilaterals will be excessively distorted, and it uses triangles to help kind of get you a better mesh in the sense of low distortion. Okay. All right, that's good enough. I think we'll leave it at that. Well, let's do the element check. So I should do that again. So here you can see I can shade in the elements or whatnot. All right, so now I've got my elements. They're in this layer. You can see I can toggle them on and off. The visibility by this little mesh icon. Likewise, the geometry can toggle on and off by the little toggle icon here. That's useful when you have like multiple components. Let's check the element quality just to show you how this goes. So under tools, there's check elements, and there's lots of different element checks, but you know, and you have different ones for one-dimensional, two-dimensional, and three-dimensional elements. So we're going to check two-dimensional elements, and let's just check the Jacobian. So I think you just click Jacobian, and here what it's done is it's highlighting elements where the Jacobian is less than 0.7. Okay, so it actually gives you the fact that 5 of the elements failed, and the minimum Jacobian was 0.63. So I've got some elements here where the Jacobians maybe are a little challenged. Okay, so I could go back and refine the mesh to a point where you know, those Jacobians get above 0.7. You know, generally 0.7 is if you have all 0.7 Jacobians or higher, between 0.7 and 1, you usually have a very good mesh. You got other things you can check like warpage. Looks like all the elements meet warpage and aspect, skew, they're all good. Well, length is, you know, we don't have to worry about length. That scales out. Really big ones or really small ones, but Jacobian seems to be the problem here. So if I don't like the Jacobian, I can go back to 2D. I can actually delete the mesh. Let's go back to tools, and I can delete the mesh. I'm going to delete all the elements. All. So I just went under. I should do that more slowly. Let's do that again. Under tools, delete. Now we want to make this delete elements. You can delete a bunch of different things with the delete command, but let's delete elements. So we're going to delete elements. And now we pick on this little element guy. This allows us to select elements. So you can pick them one by one with the little cursor, but an easier way is to use all, right? And that selects all the elements. Other useful ones you can select by window, you can select by collector, right? So if you want to do a select by window, like let's clear it, select by window, you could pick the points that define the window, the selection window. And you can see there we did that, and it selects all of them. So it's the same difference, okay? Then we delete them. And there it goes. No more elements. Okay, let's go back to 2D and regenerate it with planes. Let's pick the surface. The surface actually exists there, but let's do this again. You can see it did the really coarse one. Let's set the element size instead of 1, let's make it 0.75. Let's recalculate all in MECH. In fact, even if we want to refine this here, let's put make it to be about 0.25. We can recalculate this one to be 0.25. That's a little bit much. Let's make it 0.4. Now again, we got some pretty distorted elements here, I think. Let's put in the bias. There we go. This is going to be mine. Okay, we flipped it. All right, let's do it back. There we go. And this one will be probably -4 now. Yeah. Make that to be -4. And we can reject and we can match. And there you go. That's probably a little better. Let's return. There we go. Let's check the element quality. So we do check elements, and we can check the 2D ones, and we'll check the Jacobian. And we still got a couple of the Jacobians not so good. So you can go down and tinker with those a little bit more. But let's call it good enough. Now, probably the easiest thing to do is just to refine the mesh everywhere. So, you know, the easiest approach to do, let's go back and delete the elements again. Is in fact just to go in and just really refine the mesh completely. So let's go back and pick planes. I think the surface already exists. Yeah, okay, whatever. Pick the lines again. We'll do it again. Well, actually, I think that surface exists, right? There's a surface there. So I can directly mesh that surface using auto mesh. And that'll mesh. And you can see here I have the same option, so I can set it, let's set it to like 0.5. We'll recalculate all the 0.5. And now you can see I probably get a nice, good mesh. I can even set them all to 0.4. It's not that bad in the sense that, you know, it's still not millions and millions of elements. And now if I go back to element check, actually I think the element check is in there. Let me do this again. I'm sorry. I'm bouncing around a little bit here, but let's do that again. Let's delete all the elements. Okay, so I've got the surface here. Let's go to 2D and check the surface. So we're going to do auto mesh because there already is a surface. Let's set the element size to 0.4. Okay, and then they're going to be mixed, and there we go. First order elements, and we match, and there we go. But in here, I think, okay, I can do the checks here, actually. You can do the checks directly here, and we can check the Jacobian. And they all pass. Actually, the smallest Jacobian here is 0.78, so that's actually an excellent mesh quality. So we'll go with that, all right? Okay. So there's our mesh, okay? You can save the problem. You can actually go into things like card, like let's see. Here's a little card edit thing. I can actually pick an element. Let's just pick one of these elements. Edit. And you can see it actually gives me the C quad 4 card directly. You can edit it, but it's not really something you practically do, but you can at least look at that. Likewise, you can also look at nodes if you want to. Pick a node. There's a node. Let's edit that. And there it gives you the coordinates and all that sort of stuff. And you can go back in and add coordinate, alternate coordinate IDs and all that sort of stuff if you wanted to. Okay? All right. Okay, so we've got our mesh. I recommend you, there's lots of tutorials in here. If you go under help, under other applications, you'll see there's Hypermesh, I think. Well, I guess it's just HyperWorks tutorials. If you go under there, there's lots of tutorials that take you through all the different ways of using Hypermesh. So, for example, some of the better ones are, where's tutorials? Well, it's the desktop, HyperWorks desktop. We're using Hypermesh. You know, you can go through here and go through the tutorials on how to do 2D meshes. It takes you through all this stuff. They're not bad. I mean, even if you don't use those things day in and day out, at least you see different options, okay? All right. But that's a basic mesh. The next thing we need to do is we need to define the boundary conditions and then the load cases, right? So where we stand here is, right, we've done this step. We just finished making the geometry in the mesh. And the next thing we're going to do is define the load collector steps, okay? I'm sorry, the boundary conditions, the SPCs and the forces, and then we're going to do the load cases, okay? All right.